Okay, welcome back everyone to JETSON AI Lab Research Group. Today is May 15th, and as per usual, it would seem like a lot has changed since the past 2 weeks that we met. So we will just dive right on in here. Hey Brian, how's it going? Love your background there. You must be out at your cabin.
Yeah.
That's awesome. Okay, I'll share my screen here. Let me get things going, try and manage all this. Okay, so on the agenda for today, we have a little bit of a housekeeping that JetPack 6 GA has come out that has been like released on SDK Manager, and there's a bunch of announcements here on the forums about that we can dig into and see. Then this is a production grade release. Suhas has like all the flashing commands and stuff here for it, and summary of everything that's changed. From the container standpoint, since we like really heavily use containers in all these projects and stuff just to manage the huge amounts of different open source projects and inferencing libraries that we're using. Those containers are all compatible with 36.2, or they should be. There was some discussion about the Llama one. So some of them I've actually gone and started to rebuild. And going forward, yes, we will be building for our 36.3. And obviously recommend people change over from the developer preview to the production release to get all of these updates and stuff. And I know Johnny from the group Nunez, I don't know if he's on today or not. He's already like compiled kernel 6.8, and we also have this running now with CUDA 12.4 through JETSON containers. It ships with CUDA 12.2, but we're able to rebuild the stack through JETSON containers with all the latest. And we have PyTorch on there, PyTorch 2.3 I built too. So you can go to here and see all the CUDA 12.4 based wheels if you want to move to the latest. But yeah, it seems like we're in a real good place now with having all these like independent compute stacks and the containers for latest JetPack 6. So yeah, we should be good to go for a while. Does anybody have any questions about JetPack 6 or reflashing? You should just be able to upgrade the device through apt upgrade and not actually have to reflash it. I know some people have been out there already trying this, and I've moved on in my systems here too. There was a question about Vila 1.5, which is actually going to be the next topic we're going to talk about because it was an exciting model release back from, this was like a day or two after the last meeting we had, which was unfortunate timing. But the question, did they get it working on over Nano and on the developer preview or the GA? And yes, I do have that working on both. There were some tweaks that I needed to make with the TensorRT for that, because as I'll discuss here, we started accelerating clip and SIGLIP with TensorRT, and I needed to change that around how it was being done on Orin Nano. But yeah, so the Vila team that we work with, which is like a consortium between MIT, HonLab, and NVIDIA here, has released Vila 1.5 model, which has a bunch of enhancements from not only accuracy, but the performance is now much higher as well. So we can see the benchmarks here. They were all state of the art, or was state of the art 2 weeks ago, given like how fast things move. But I always take these like actual like MMMU benchmarks and stuff with a grain of salt and kind of go by what I'm used to doing, which is like live video streaming and things like that. And really kind of importantly for us with these edge devices, the performance has drastically improved, like 2 to 3x, up to 7.5 frames per second on the little mini model. So this is now a 3B, and it's trained on the same shared Llama 2.7B that the original Vila mini VLM was, but it now uses a larger vision encoder called SIGLIP, which is like open version of CLIP. And that model, they used a larger image resolution in that. I think it's 384 by 384. So that's where like the extra 300 million parameters come from in that. And essentially how they got it to run much faster is before, when everyone was using Clip 336, that produced like 576 image tokens per image in the chat. And what they've done here, the researchers have found that if you have a higher input image resolution into the vision encoder, then you can actually reduce the number of tokens through the projection layer, and it like works even better. So it's the spatial resolution is more important than the number of tokens that it adds into the chat. So now it only does 196 tokens, which makes the LLM prefill and generation way faster. So we can essentially do 3 images in the time that we used to just do 1. Okay. And there are a bunch of other examples on here. At the time, I did not have the full video streaming working, but I just released a video on YouTube that let me pop this in the chat here real quick for you guys so you can watch along. Just not through my browser here. One sec. Here we go. Okay, so all the live VLM stuff we were doing previously was on one image. It was running, continuously streaming, but it did not incorporate temporal data into it. Now, this particular montage of video clips is running on a rolling window of 8 image frames. So the past 8 images from the video sequence that it's processed, it does that. And by virtue of that, it's able to do better like action recognition, video summarization, change detection. And we'll get into a second. There was a bunch of enhancements that I needed to make into like the KV cache manipulation, being able to pop tokens off of the end and like change the chat around, manipulate the KV cache. So essentially how it works is this is just running on 8 images because I found that 8 provides a good balance between keeping the chat up to date with what's happening most recent, but also providing enough background into the past window. But like, so 8 times 196 or whatever, there's only 1,600 tokens. Okay, it could actually do like 32 frames per 4096 context window or 20 or like whatever it is. But we can see here, like, it's quite responsive. When the fire broke out, in like less than a second, it had picked that up, even though like the past 8 frames, it had like an 8-second window in that if it's processing at 1 FPS. So these are just a bunch of clips that I either found or like took outside my house here just to like mess around with things and see how it goes. But this is exciting because it basically wraps up this awesome vision language model building block primitive that we can then take and drop into our agents and for doing much more complex video queries and things like that. So and you guys can go and check this out. I did just update this page with the command to run this. I've not integrated this all into the actual like GUI and stuff yet, but I will. But right now you can go through here and like process example videos that you want and see how it runs. Or you could just point this to like a dev video 0 camera and it'll run on a live camera instead. And you can mess around with like how many image frames you want it, how many tokens per image it's allowed to output. I cap this at like 2 to 3 lines in that output. Otherwise, it'll just keep going and going, and then it'll slow down the stream, right? But this is all in here. The code for this is also up and is quite simple. It looks like the example code for the previous live lava example. You just see here that there's more like video streaming stuff in this one, and it does like the font overlay. But here is the more important part where now it's adding like multiple images into the chat without resetting it. And it also pops the most recent query off of the end here. So like every time it outputs text and the question, I think currently the question I ask is like, what changed in the video? Well, it'll pop that most recent question and response off of the end, add the new image on, and then ask the question again. And I found that works better so that like, it doesn't taint its future responses based on the previous response that it had. And all of this like KV cache and chat history manipulation is what I was actually working on for like the past week and a half to get all this running, and is also applicable to just like general long context chatting where you like want to wrap around the chat or save parts of the chat if you get beyond like the 4096 or 8096 context limit. So in order to do that, I exposed this new like KV cache interface through Nano LLM, which is this is like an abstract interface, but basically just allows you to either pop tokens off the end or remove tokens from the middle, which is generally like a no-no, because LLMs being auto-regressive, you can like blow up the thing's memory with this and it'll just start spitting gibberish if you're not careful about what you remove. With the video streaming, it does actually work okay because that last image in the frame is generally non-consequential by that point, and it's such a structured chat that it doesn't totally blow it up. When I was developing this, I tested it through this like higher level interface to it, where now you can like use this deletion operator on the chat history, and it'll go through and not only remove it from the list of messages and like the web UI and stuff, but then underneath the covers, like remove it from the KV cache also. So if you were just to like delete the message off the chat history, but not remove it from the KV cache, the bot's internal memory would still see that message there. And the way I tested this during development would be like, the first message would be like, hey, my name's Dusty, and then ask it what my name was, and then go back and delete those messages, and then ask it again what my name was. And when it stopped realizing it, when it couldn't answer what my name was anymore, then I knew that it worked, and confirmed that it had actually successfully deleted it out of the bot's history. This is all pretty like low level manipulation stuff. These KV caches get like very large in GPU memory, and when I initially started doing this, it was taking a lot of time, like hundreds of milliseconds, because it was like transferring the memory back and forth, just using like NumPy arrays to do it. But I went through and like mapped it into CUDA memory that you can like see here. This is all in like the guts of MLC, how this is done. So this is the actual implementation of the KV cache for the MLC API. And basically what it does is it maps the pointers first from the internal MLC representation, finally finds the CUDA pointer, and then it literally is doing CUDA mem copies on the KV cache to like move that all around internally. So this took a while to like line all the tokens up and make sure it was all going. But overall, I'm quite happy with how the performance of it and everything turned out. And now we have full video VLM at like 7.5 frames per second, and we can do a lot of stuff with this. Okay, let's take a second and answer any questions here. Chris, you had your hand up.
Yeah, I think I had two questions here, and I think my first question probably changes depending on whether you're working with a local LLM or whether you're using like a, OpenAI API. And it's whether you can so for example, if I was running a history of the chat, because I wanted to, for example, have it where it can summarize what it just saw. And so I wanted to keep the history. But so is it safe, for example, for the sake of tokens and for the sake of performance, to delete just the images out of the history, but not the chat itself?
It really it depends a lot. Sometimes it's more sensitive to certain things than others, and it might blow it up and then just start spitting gibberish out. In most of the testing that I've done is deleting like the very first, like keeping the system prompt, but then deleting the first couple messages after that. And in this example, I am deleting chat text from it because I have that like image number before it, and I delete that also. But this is something that you gotta play. You can safely pop tokens off of the end of the cache, off the like the most recent ones, because that's like mathematically sound. It's when you start going back into like the middle or beginning of the chat, because like technically every token in the KV cache depends on the sum of all the previous tokens and like how they're all interlinked to form this embedding like notion of like a thought or memory in there. And all of the tokens are kind of like networked together to form like the concept of it, right? So if you go and
it's like a neural network
those,
kind of.
yeah. So it seems to work okay on images because like it's just an image and the images aren't that different. My guess is if you can, like in the Vila blog, you can do this with totally different images from like days apart. Or one thing I want to mess with more is like the sampling rate of this. So right now I'm just running it as fast as possible. But you could say, oh, I want you to sample every minute or hour and tell me what changed over that, or do like a video search thing. And I think there you have to be like more careful. But this is obviously still like an experimental thing, and you can go and mess around and see what it does.
And my other question is have you experimented with doing summaries of X amount of time as opposed to what's changed like from frame to frame?
I've not yet, but I know like the Metropolis guys are more into that, and I think we'll get more into it. And I hope now that this code is out there that yourself and others can go off and start doing that too. I will integrate it into the web UI so you can set that like there'll be a slider for like the maximum number of images in the history and also like the sampling rate of those images. And I'm debating whether I should add like video file input into that web UI, or should it just always be live streaming camera thing? Because it's meant to be like a playground for these as opposed to like an actual visual agent or whatnot. But we are progressing in that direction. So we'll obviously, if you have any feedback on like what you want to see like functionality wise in it, let me know.
Yeah, I think a fun demo on what you have would be to upload a file and then ask it to summarize what that video
Yeah,
was
it seems
about.
like with the video function, it's way more pertinent to have actual video files to play around with. So I'll probably do that. And when playing with in person, there's a limit to what you can demo. There was a question here about the FPS of the input video dramatically changed on the token spent. That is entirely correct. Yeah, the performance is non-deterministic based on how many tokens the LLM outputs. And the benchmarks that I put out in terms of FPS is always for just like a yes/no question. So like just like a couple tokens output. And then from there, you can say, oh, well, this is the baseline FPS of the thing. And I know that this model does 45 tokens a second, and you can just add that on to the latency and get your like desired FPS. But that is why I always cap it at like 32, 48, 64 tokens, which is actually like kind of even more than you want at that fast rate, because otherwise it'll just keep going and getting more and more detailed summarization of the video.
Dustin,
Okay.
I made that question, and that the reason is there's another metric that maybe could alter this. How complex the video is. I would think that the more explanations this system has to give, the more tokens it will spend. Or I'm getting all messed up.
You're totally right. I think what you're getting at is like these like chain of thought style prompts, or it might, based on its initial output, you might want to go back and have it output more. And most of the agents we've done to date aren't like recursive in nature like that, but a lot of people are doing that. And I think that we'll get there where, you know, these chats are going to evolve, and we'll talk about like controller LLM later, where we're at on that, and function calling. But it might be that like based on that output of the VLM summarization, the controller LLM wants more info or asks it another question to follow up, and then goes back for more info. And this can just keep happening like ad infinitum, basically. So I think over time we'll get like the agents more and more complicated like that. Mike Bruner from Ridgerun, you had a question. Sorry to keep you waiting.
No worries, great stuff. Just trying to tie back these to the Home Assistant. Is there something missing, or can you think of a concrete task to start porting that to the project?
I think what's missing is and I don't know if the other Mike from Nabukasa is on today. It doesn't look like it. But last time we chatted about this, they were defining the APIs for advanced AI functions like image queries, video summarization, image generation. Okay, Mike's here. If you want, Mike, you can let us know where you're at on that, like the definition of these APIs that we would then hook into with it. Otherwise, we would like do it out of band essentially. And I know there was discussion of that not only these like AI agent APIs they're going to expose, but also the notion of like a virtual sensor in Home Assistant, where like the VLM would be like a sensor that outputs into the system that or like augments metadata of the image sensor in there and ties into the system that way. So I think we'll like hook into it at multiple levels. But at this point, like you guys can feel free to go start integrating this stuff with Home Assistant pipelines, however we can do it today. And I don't know, Ms. Zago, if you wanted to chat quick about the stuff that you're doing with the Home Assistant supervisor, or your take on how to best proceed with integration from here. Sorry, you're on mute if you wanted to. There you go.
Yeah, that's it. Could you repeat please, because
I wanted to get your take on how we should best proceed next with the integration, because I know you've been working on like the Home Assistant supervisor to make all the Wyoming pipeline easier to set up. But in terms of like adding in our agents and vision language model capabilities, given that the Home Assistant APIs aren't formally defined yet, what is the best avenue for us just to hook it? Is it just via like the REST API and do it out of band, or like, what do you think?
yeah, so as you said, I know that Home Assistant team is currently working on exposing intents as tools which could be used by LLMs. So that would be a cool feature to be supported by existing integrations already. So during that time, when guys are working on the pull request, I'm trying to port supervisor. Didn't have much time to work on that, but I moved a bit.
Yeah, that's a big heavy lift too. So
yeah, it is. But I moved a bit into the stage when I have it Dockerized. So supervisor is just missing some Docker volumes configurations, and it should work, I think. So basically, at this point, we are improving the user onboarding, and later we need to sync with Home Assistant team to expose those APIs for advanced and now working with images or videos in real time. we still, I think, lacking that. And having that will allow us move forward with advanced stuff like custom integrations from JETSON and etc.
Okay, so we'll try to get more clarity from Home Assistant team on like what their timeline is for this. And I think we're all kind of like going together. Oh, Elaine from C, do you have any input on the Home Assistant stuff? Are you there, Elaine?
Mute? Oh, okay, I'm good.
Yeah, we can hear you now.
Yeah. So actually, I know Miasco, you're working on the supervisor. Will also evaluate that. But so currently we're saying, so we have configured the Whisper whale main and the ASR TDS, but we haven't figured out the LLM part. I mean the LLM or the VLM. I mean the models part. So the road will be if we figured the supervised, and then we have all the peripherals. I mean the Whisper Wyoming work, but in the central thing, the models we didn't figure out. So we can choose a figure supervised and then getting the model working with the peripherals, or either way, now we evaluated, we prefer to get down of the models first and then to connect with our peripherals and then go back to supervised.
Okay.
Because we reviewed the repo, but it seems like it's still a long way to go. So now our team now is maybe prefer to the second option, but we have a mic here. I want to hear more suggestions. What is the more efficient road we can work together? Yeah, and also, by the way, we have a project called Remiro. That is we're using the OpenAI API, but we tried using the Llama 2, but the performance is really bad. Yeah, so I think there is still a long way to go and to choose like the models.
The accuracy or the inference runtime performance?
Oh, the accuracy.
Oh, okay. Yeah, in comparison to OpenAI's, I'm sure it will be. But I think the Llama 3 has been better, and maybe we'll find some way to run the Llama 3 400B when it comes out. But we'll see. But even so, that is nice to provide that capability. And Dave, I know when you did the GLaDOS one, you were using ChatGPT API and then changed it over in like an afternoon to a locally run OpenAI server, which seems like the easiest way for people to do something. So in the chat, I dropped Home Assistant's existing API hooks for LLMs and their conversational agent. So this is how today, if you just wanted to like plug Llama in, you could do it that way. But I think suffice it to say, there are multiple levels at which we can integrate, and we want to do them all and support like the existing voice pipeline, this conversational agent, which like, yes, Mike said that this is going to change and they're going to add more of these primitives, and when those are defined, we'll integrate into them. For now, since those are in flux, it might be easiest just to do this like more out of band or through like the Home Assistant REST API, query all the devices and sensors, put them into the system prompt and like try to do function calling and quick experiments like that. And until like the actual APIs are defined. And I think we're all like working on it together. Like every couple of weeks, we're continually coming out with these new generative AI powered functions and features, and they're trying to catch up on their end, and we're trying to catch up with integrating into what they have now. So I think like take this, start playing around with it, and I'll do the same now that we have all this going. There was a question I missed from the chat here real quick. in the case of video processing, is there a pre-processing step to preserve some part of the image data, or is most of the activity in the image in each frame, or are we processing the entire image directly? So how the pipeline actually works is every time the LLM finishes its text output, it grabs the latest image from the camera or the video stream. It puts that through the clip or SIGLIP vision encoder, gets the embedding for it, adds that embedding to the chat, and then reruns the LLM generation. All of the previous images that it had ingested and encoded are still in the chat until it reaches the maximum number of images in the history, at which point it goes back and removes the very oldest image and drops that off, and it's able to like keep running forever that way. Okay, this sounds good. We can shift gears for a second. I know one of the newest containers that it came out, Martin Cerven had made one about the Voicecraft, which is was really cool and seems like quite pertinent now with that OpenAI did the ChatGPT 4.0, which has like integrated ASR and TTS into the model, and I think this Voicecraft container is a little bit in that vein. Martin, I don't know if you like wanted to show this off, or if you wanted to show a demo or anything. You can do screen share and talk us through it.
Yeah, for sure. I can.
Awesome. Yeah, I'll pass the ball to you. Thanks, Martin.
Can you hear me?
Yes. You're a little quiet, but we can.
Okay.
Okay, we can hear you better.
I'll try to share the screen. Okay, entire screen. Let's do it. Okay, I will just start talking and maybe. So the Voicecraft, I'm not the author of the paper, but I made this container. And
if you're trying to share your screen, I don't think we can see it yet.
Yeah, I know. Okay.
Okay.
I will try to, because I'm in a headless mode and I'm on a Mac, so. Oh, can you see at least Firefox?
Yeah. Yep. We got your screen now, at least of the
So, okay, I'm gonna start the container. Basically, it's a speech editing, but also TTS. So you had a container for AudioCraft. Can you see the?
Yes. Yeah,
okay,
we can see it. We can see it. Thanks.
Okay. So this is basically radio. It's like for showcasing models, and here you can select model. Basically, how it works: you have an audio, and then you can either edit it or use or do a TTS, and it tries to mimic the voice of the speaker. So for transcription, it uses WhisperX, and for the generation, it uses the encodec of the Facebook. It's an AudioCraft container. So awesome. I can load, yeah. I don't know if you can also hear the audio. Let me see. Can you hear? Can you hear something or not?
No, you might have had to select that when you shared your screen, but we can also go in and try it also. You can try resharing if you want.
Okay, let me try.
Normally there's a box that says like select or enable share audio. But yeah, this is interesting. It does like the whole ensemble and voice cloning at the same time, and I think we will see more of that type of thing in the future. I'm totally fine with having like ASR and TTS be like their own things, but it would seem like these models are moving towards that way. because what we do, we've been working on further optimizing Whisper for the Over Nano, and have that smaller and faster than the original faster Whisper even was, like 35% faster with via TensorRT. And my point being, like, oh, you can change out the ASR and TTS backends and models based on the device that you have. If you can't get it to share with audio, that's okay. We can go in and play with this. And I built these containers. They're like up there now. And I mean, in your experience, did the voice cloning and sounds good? And I know voice.
It works surprisingly well. I wanted to show you something, but basically, okay, I'm just gonna, you can try it at home. So
okay, yeah. Well, I know that there's like, you can just run this through their Hugging Face video too.
So you select some voice.
Figure out sounds, but yeah, like show it actually running so we like see the performance.
So you step one is like you transcribe it, and this is done by Whisperx, and these are the times of each word, and then you can use either TTS or like editing. I usually like to do some TTS, and then you can write some kind of text. I don't know. I want to have JETSON and 28 GBs of RAM.
You're funny, yeah.
And then, for example, and this this prompt, this is the part of the audio that you, because you have two parts. You have the textual description, this part, and then you have the audio part, which will recreate the voice from. And then you create run, and will start processing. I wanted to show, if I share this whole screen, I probably found a bug in JETSON stats, because if you type a long sentence, you can crash the container, and there. Okay, so generated new problem.
Okay, gotcha.
Maybe if I could
All right, it seems like it's playing, but like we just can't hear it, unfortunately. If you could download the audio clip and drop it in the comments, we might be able to listen to that. But this would seem like apt, Martin, that you did this. It was like early last week that you did this, and now these unified like speech LLM omnimodal models are much more prevalent because of OpenAI and ChatGPT 4o. And not that like you can look up like ImageBind and other encodings, and yes, this Voicecraft was out. So I think the research has been heading in this direction some time, and is good for us to support and look into more. And I know that like other vision language model teams and other ones are starting to look at this too. And obviously like this only kind of makes it simpler for us if we can just like pipe in all the sensors to the thing, and it outputs text or audio and all these modalities. And I was reading a little bit about this. Some of them, these omnimodal models, you can enable it to output like the actual chat text history that it gets. And there's a lot of debate going on like the Reddit forums and stuff about like how this actually is working and stuff like that. Okay.
You can also try the Voicecraft container. There were some minor bugs, but it's also working.
Okay. Yeah, I do have that built on the JETSON containers. It's up here, so you guys can go like play around with that and integrate it into. Here it is.
And I wanted to ask, like the Chitoku made also like a pull request on Whisper streaming. I also made it working, so I don't know if he made it working too, or it's like a work in progress.
Yeah, we have been. Chitoku can speak to that, and Chitoku is going to present next on the JetBot too.
Yeah, I haven't, to be honest, I haven't been working on the Whisper streaming. But yeah, I think
John
it's
has
working.
though. Yeah.
Right. So maybe we should wait until he comes in, he jumps in. But when I was testing as it is just based on faster Whisper, and the real timeliness, it wasn't that real time. On the simulation mode, it kind of goes well, but
I
like
think
once you start typing in with microphone, it didn't.
when John dug into it, he found that faster Whisper in streaming mode was just putting it through original Whisper in 30-second chunks, which is why the streaming wasn't working good. But then I don't think he's on the call here to speak to it. Let me check. But he essentially optimized with TensorRT, got it 35% faster than faster Whisper even was, or like 3x faster than the original Whisper. Implemented some high-level streaming stuff and voice activity on the top, and we'll have that out in the next couple of weeks on GitHub and like integrated and everything, and into the ASR TTS stack. So at that point, we would then be using this like Nano Whisper and Piper for Orin Nano at least. We'll see. I still think like once they do fix the Riva TTS, that voice does sound really good if you're on AGX Orin and can afford the memory. But like we want to have like the lightest weight, lowest overhead ones that we can. Okay, so with that, another thing we've been working on the past couple of weeks is updating JetBot for Orin Nano and the Nanosaur as well. And like CMU had been working on that. I think I saw Jesse from the call here. So Chitoku has been working on that and not only updating the containers, but like getting like the battery situation figured out. So Chitoku, I don't know if you wanted to show any latest progress we have there.
Yeah. Hi everybody. So yeah, I'd like to quickly just sort of give you an update on our JetBot sort of debugging activity. So let me share my screen. I have already put out, we have this page newly set up. It's a bit of materials, but Orin. So this is a set of new parts that we figured it would work. The main thing is the power source. So it's actually pretty simple. There are nowadays this USB power delivery power back that can negotiate at 12 voltage or even higher. So just taking advantage of it with this PD cable, it would then just output 12 voltage. So I'm not sure if you can see my sort of webcam feed. This is the JetBot already retrofitted with Orin Nano. And this is a new battery pack, and then it is just connected over this. So it is.
Okay. Chitoku, can you turn off the screen share so we can see your actual
turn off the screen share.
yeah, so we can see your video bigger.
That's right. Okay. You may want to sort of select my video feed.
Yes.
But this is it. So it is just how it is. I can later set up the hardware setup page for Orin, but it is simple. So I'm pretty sure everybody can sort of follow along if people are interested in. It's even more simpler for the case of like WaveShare JetBot, since it already has like 3 lithium-ion cell. So I haven't yet like swap this out with the Orin Nano, but it is as simple as almost sort of taking the low like lithium-ion battery output into JETSON Orin. So that can be done pretty quickly, and you get the benefit of sort of like UPS functionality of the board. So that's probably better, but I'm just demonstrating this. Now, of course, this needs to work with the software. So I just want to give you a sort of sneak peek of what it is like for now. Let me turn off my, let me share my screen again. So right now I'm just connecting over USB with USB device mode. And the idea is to use JETSON containers, our beloved, framework that's set up, JETSON containers to create a JetBot container. So I have already built it with all the things. So yeah, you can just like run it. And maybe again, I'm gonna just, it's running not right now, and OLED shows up.
Oh, nice. Yeah, okay. So I saw, yeah,
Well,
you added the
I'm not-
OLED component container
Yeah,
too. All right, nice.
I hope you can see, but
And
with
those little
this-
OLEDs are really handy for like anybody that has a headless device, even if it's not JetBot or whatnot.
True. It might be good to even like integrate this with Raffaello's JTop. I was sort of like discussing with that.
Sure.
Maybe we can get some idea with people. And the Jupyter Lab. Sorry, I cannot get.
It's
that
okay.
thing
You got a
working.
lot going on there.
Jupyter Lab is with this. Jupyter Lab is up. So
Okay.
yeah, that's how it is.
Yeah, we
I
trust
don't
that
know
it's
why
like,
not.
yeah, you're getting the notebooks back running the way it was. And so
Right.
you've done a great job basically getting back to parity with like original JetBot, but now it can be on the over Nano updated but in the background, CMU, Jesse Flott from CMU Robotics Academy had made a whole bunch of like new content with ROS and reinforcement learning and simulation and SLAM and all this great stuff that and he came out with this great course. Unfortunately, then the original Nano went EOL, and that's why we've been like updating this all and working with him. And we hope that Jesse, we can all work together to at least direct people to all that great content and learning material to integrate like Gen AI features in there, speech services onto JetBot, and hopefully be able to take some of that stuff and either have you like merge it back into the JetBot repo or somehow make it so that it can be used in all the other ones too, like the JetBot or like the WaveShare and SparkFun and Seed Studio ones, and that you can just like get from Amazon.
Right. My immediate goal is to get it set up and then put it out there so that people can sort of work on it. I'm just trying to make this sort of available for people who are interested in.
Jesse, I see that you're on the call here. I don't know if you wanted to chat real quick about like the direction we're all heading with this, or I would love to come in sometime to NREC and we can sit down and chat it together. Oh, Zayed's here too. Zayed, do you want to hop on? Zayed's also from CMU and has done a course with JetBot like robot that he's doing and presented here a few weeks ago.
Yeah, no, it's great to see the battery setup. It's similar to what I did for the autonomous robotics course at ECE here. The question I have is, the battery have power delivery negotiation with the Aura Nano? Or how does it, because the battery has multiple voltages, or how does that work?
It can negotiate at multiple voltage, but you are using I'm using this cable, sort of it acts as what people call trigger. So like this itself has like my little circuitry inside that try to negotiate at 12 voltage. So once that is successful, it's just going to spit out 12 voltage on this DC power plug.
Oh, great. So if you can share that with us, that would be great. I would love to try it.
Just to share for everybody, every type of power bank or power supply for your laptop, which is just an example, can supply more than different type of voltage. Example, this is a power bank. You can see here a label. Well, now looks a bit impossible for you, but if you try to open to take one of your that for sure you have at home, you can see different output voltage. Usually are 5, 9, 12, 15, and 22. Because now for the new standard, every type of power bank or a power supply can deliver a different type of voltage. Example, you can use your power supply for your laptop to charge your phone and different other things. And we can use this power delivery example to bring not 5 volt voltage, but more voltage. Because this type of power banks or system need to communicate with the chip and ask, because in the beginning always work as 5 voltage. When with this chip, you ask this chip ask another type of voltage and switch to 9 voltage, or for only or is yes, just for 9 is enough. Sorry if I interrupt you, Chitoku.
No,
It's
that's
okay.
a good point, Raffaello. It's just that the Orin Nano, I thought the barrel jack is passive, so I'm always wondering about how does that work with that battery supply that requires negotiation.
Right. And then oftentimes people get a little confused because it has a Type-C receptacle, but it doesn't take the voltage. So yeah, just a note on that. So we need to rely on such external power negotiation circuitry.
So I went in the chat, I posted the battery that I use for my wearable. It may be too big for your bot, but the power supply that I posted there, or the battery I posted there, is really nice because you can set the output voltage and it has a barrel jack that
Oh yeah, I
uses
actually
that
have
output
one of
voltage.
those.
Wow.
Chris. Yeah, those are nice.
It's massive, this one.
Yeah, so that one obviously may be a little overkill for the bot, but that gives me a couple of hours typically on my wearable.
Yeah.
Yes, that's cool.
And Raffaello, while you're on, thanks for joining, because I know you before this call you do the Isaac Ross office hours. But in Raffaello, you've also been updating Nanosaur, which is another JETSON-based robot that's based around Ross, and have been updating that for not only the latest Ross, but also over Nano and NX and stuff like that. And also been a part of these ongoing discussions we've had about like the common Ross infrastructure architecture of our different educational robots, including JetBot, Nanosaur, iRobot Create 3, TurtleBot, and like all of these others that we would like to have some shared, software between, so that when we go and add like the latest Gen AI stuff or LLMs and keep building on top, then not everybody has to recreate that from scratch. And Nanosaur already has a huge amount of Isaac Ross integration and SLAM and navigation and stuff. So I don't know if you wanted to talk at all about your plans on like updates you want to do on the Nanosaur side, and like how we can all merge that back together, kind of like we want to do with CMU and the great coursework they've done too, like kind of take the best of everybody's.
Well, thanks, Dustin. Yes, well, there are some progress, not in this period, to be honest. I was doing some tests some months ago. Like this is a new shape for Nanosaur, changing from track to Omni wheels, adding also...
it looks like a little pickup truck.
Yes, exactly, because the reason I noticed many people 3D printing TPU is not so simple. And
the track, I remember that it was the cutest little robot with the tracks, but I remember you saying it was difficult to print those.
Yeah, not for everybody. Yes, I noticed many people have issues to 3D print TPU, and also working with 4 wheels can move more heavy things. Like I can use also LiDAR. This is the idea. Well, of the chassis, there are some things that I want to add also, like Chitoku was saying, for the power delivery. The idea was to use, maybe you can see here, or a LiPo battery or a power bank together. Like you can use a power bank to switch up on the robot, or a LiPo battery in this case with a new shield. You can also manage and control the power on the robot. Example, if the battery is switching down, you can also switch the robot, something that you cannot do with a power bank.
Sure. Zai, did you have a question? You had your hand raised.
No, I apologize.
Okay.
Trying to lower my hand, I ended up.
Okay. Well, I think Al has a question. Do you have a question?
Yeah, I posted it. It's just that for some reason Teams misbehaved and all this stuff, all the links are gone when I came back, and I cannot find the link of that list, material list. And I wanted to know.
I'll post. Okay, I'll post it again.
Yeah,
for you.
I wanted to know where to buy that Wonder power bank that Raffaello showed it.
Well, technically, this power bank you can find on Nanosaur. This is the same power bank I'm using on Nanosaur, but but more or less now every type of power bank have this feature. It's mostly looks like mostly impossible to don't find.
Okay. Cool.
Okay. It would
yes,
still,
it's important.
seem like
it's written at PD power delivery.
It would seem like we're still in the mechanical, electromechanical phase of updating these robots, and hopefully in another couple of weeks, maybe by the time of the next meeting, we'll be more in a position to discuss like this common ROS-based software infrastructure, and because like understandably we're updating the battery components and like everything to get all of it just running again and getting all the software back up and running on them. But then in the future, yeah, we do want to have some both keeping, like I remember seeing you said last time, like, yes, they do use the Jupyter Lab notebooks in like the first half of their course for high schoolers and undergrads, but then they do change to ROS. And I think that's where we'll get a lot of the really powerful features, essentially being able to put the LLM on top of the Nav2 stack and SLAM and NV blocks and all of those great GPU accelerated gems that are already in Isaac ROS, which is very powerful. And we also want to work with Isaac ROS much in the same way that we have with Metropolis team to upstream a lot of these awesome new vision primitives and Gen AI tech into those and into ROS, so that they'll get rolled out across the community and developers and stuff. Okay, we have one more topic. Okay, Jesse, do you want to, you have a question?
Yeah, quick question. What's the possibility of rolling like the Isaac ROS software requirements into the base SD image moving forward? Like I've been personally, fighting for about a day and a half to get it built and running. Up. Just like the BuildX plugin that it relies on is like elusive.
You mentioned something about the BuildX. So it uses Docker BuildX. Is that right?
To do the sensor building part, at least, yeah.
Interesting. Okay. Yeah. Well, I mean, Raffaello is your guy. He's the lead community guy. He's like me, but for Isaac ROS. So I think like you guys can hook up. I'll send you Jesse's email. I think you might already be on.
Sure, yeah, no problem. Yeah.
Yeah, he's the ROS expert of us.
Or also feel free to open a post on the Isaac ROS forum that I will be the first person that read and reply and or
sounds good.
Forward to the engineer. Yeah, no problem.
Yeah, sounds good. And like my specific use case aside, just empathy for the types of classrooms and students we're trying to support versus hobbyists and developers. Like I
understand your pain, and I think like if you go into the SDK manager to flash JetPack 6 GA, you will see this new JETSON services coming soon box, and that will include these new Metropolis vision primitives and microservices and stuff, and hopefully also Isaac ROS in the future, and be able to add all of that in there. And yes, we do realize that we're like updating on these JetBot containers, and it's still an open question of like, do people still want the SD card distributable, and should we make a tool that builds the SD card images automatically, much in the same way that we build the containers automatically? And that could be extended to just like you said, like you finally figured out how to build your ideal Isaac Humble based container, and then you want to build the SD card image around that, so your like dozens of students don't have to, they probably don't even know what Docker is at that point,
Right. Thank you.
Just to spend 1 minute before the end of this meeting. We are releasing soon the new version of Isaac ROS 3. This is important.
Right. Yes.
With really a lot of new features for robotics, new updates and will be released really soon. If you're already working on it, you enjoy.
Yeah.
I don't know the day, but I can see and testing also.
Okay. Yeah. But let us know when it comes out, Raffaello. And I think it's great that at the same time you're like updating Nanosaur, so it will be primed and ready for Isaac Ross
Okay.
3.0, and we'll get more of the Gen AI stuff in there. Like we have a node for NanoL right now. We need to go back and do more for like general LLM stuff and VLM stuff. But okay, so we do have one more topic to cover quick. It would seem a lot of these meetings we go like an hour 15. It seemed like what we settled on here. The last, okay, Zaya, do you have a question, or was that a spurious hand
Yes,
raise?
actually. I mean,
Okay.
Dusty, you were talking about moving from the electromechanical to the Isaac Ross with Isaac Ross
Yeah,
3.
and we want to
reflect on-
merge all that great work that you've done and Jesse's done and Raffaello and get that all like presentable to everybody.
That's where I would like to see that would benefit us really greatly. So the question also is how much of the machine learning models, like segmentation, for example, can we run that on the Orin Nano? Can we do MV blocks?
I think you can do all of them independently, we found, but like doing it all at the same time in like a cohesive autonomous navigation pipeline, that's obviously pretty challenging. And it's a similar problem to what we're facing with this, our goal of getting the all-up multimodal agent running on over Nano
Right.
8 GB too. It's like we can play with all the components independently, but getting it all to run at the same time in 8 gigs is. And you could also source like an Orin NX 16 GB from Seed Studio or other distributors to at least demo it to your students, running it all up, and show like the full-on pipeline. But yeah, there are limitations there, and that's something we'll get together and chart out like what's the memory usage of all this
What's
different
possible,
stuff.
what's not, yes. I mean,
Yeah.
it would be, for example, really nice to see Visual Slam with object detection, for example, running together. The question is,
Yes.
can we do it?
Yeah, I would love to see like a Nav2 based autonomous navigation path planner with SLAM on it, and then on top we have like NanoOwl object open vocabulary object detector running, and then like speech services and things so that you can talk to the robot and tell it what to follow and what to do, and it goes and maps all that out. But we'll see if we can fit that all in 8 gigs. That seems it might be a challenge, but we've made good progress on our memory optimizations to date. So that is our goal with this group, is to make this advanced AI accessible to everybody at the entry levels, and we'll be continuing what we do here. Okay, so last topic that we want to cover real quick, because it is important to the overall architecture, like we keep hitting at here, is the controller LLM and function calling and RAG. So the last meeting that we had about this, we had just put out this Llama 3 based function calling using Python functions and such. And it is a good proof of concept, and you can use this for simple stuff. It's very fast because the Python syntax is short and doesn't have a lot of extra tokens. Like a day or two after I did that, News Hermes launched this Llama 3 Pro that is specifically fine-tuned for RAG and function calling, and uses this OpenAI style tools in their chat ML chat format. And let me zoom this in for you. So I'm now that I finished this video VLM demo, I want to go back and add support for this too. You can see how it embeds the tools. Actually, maybe I need to scroll down a little more. Where's the tools? Here they are. Okay. So it has this specific JSON format for embedding these tool functions in there. And like this one is a description of a function that does get stock information. And these can have a lot more parameters to them and are more complicated than just like the simple Python examples that I had provided. And I'm going to adapt the function calling and the function decorators and stuff to support this different chat template format. So the way I did it before was essentially inline function calling, where it happens at like the token generation level, the same way that it would be done with like grammars or guidance functions or things that happen token by token. So this happens like inside the generation thread, and is done like inline essentially. This way is done inter-request. So meaning that like the LLM, when it wanted to call a tool, it would do this. Its reply to you would be tool call, and then at the end of the entire request, we would look for this tool call with a regex, and then add to the chat the tool response, i.e. like execute the function and put it back in there, and then allow the LLM to continue generating from there. So this will be slower because not only is the function calling much more verbose in like the number of tokens, and it's done with multiple generation steps as opposed to all like inside of one. But it would seem like this is much more capable than the initial just like baseline Llama 3. This was fine-tuned explicitly for this. News Hermes does awesome fine tunes, and some of my favorite models are from them, and also like Stability AI, Stable LM. So yeah, I'll drop the link to this, but this is what I want to work on next in the controller LLM arena. And I hope that this is able to do complicated enough stuff that we get to the point like just exposing it all these different vision primitives that we have, NanoL, the VLMs, all the audio settings and everything, all the home assistant sensors and devices that you may have, expose those all through like this more verbose tool descriptors in there. And like the system prompt might become like hundreds and hundreds of tokens, which is fine because it can be cached and we don't really need like super long context for these like brief user chats anyways. But I think this model does show a lot of promise based on some initial messing around with it I did at the playground. So at that point, we will have both inline function calling implemented and be able to do guidance and grammar and guardrails and stuff at like the inter token level. And then we will also have inter generation level tool calling where like there's multiple replies. And then I think at that point we start getting more into like these chain of thought style agents where it goes off and is like doing multiple replies in the chat. And eventually you get to the point where like this chat will have multiple bots going back and forth between it. Like the controller LLM calls the VLM and it goes back and forth, and you might say something to it and it injects text from you and puts a response back to you. But it's like a multi-agent chat at that point where like you're just one of the agents participating, and there might be events or alerts that get triggered and add events into the chat. So it should be pretty cool, I think. And we want to build this all up, you know, multimodal vision agent that you can speak to and like reconfigure the whole pipeline, whether it's on a robot or smart camera or whatnot, and have it all tied into the RAG system. And along those lines, we have the multimodal RAG integration running, but Chitoku has also been working on more introductory RAG samples just based on text that can help us not only make like cool little bots to help us during development, but everybody is curious about how to get started with RAG and how it's most easy to do that. Not everybody needs the full multimodal. It's easiest just to get started with text only. So Chitoku, I don't know if you wanted to take back over and show what you've done with LlamaIndex and those great samples that you've been working on.
Yeah, let me again just quickly share the screen. Those are actually already sort of in the JETSON containers.
Yeah.
So those people interested in just can sort of run those container. It's with samples. So this is LlamaIndex samples container. So if you launch it, it comes with JupyterLab. It's built with the JupyterLab. By the way, I just updated to the latest 4.2.0. It seems working fine.
Thank you. Yeah, I know that was kind of annoying, but it's good to have. And this is also built on top of Ollama too. So we have a concerted strategy here to direct people to Ollama, LlamaIndex, Jupyter Lab, because it's like easy for people to get started with. And then from there, you can graduate to like the much more advanced agent and real-time multimodal and all that stuff.
That pattern seems to be working pretty well. So this container spinned up an Ollama server, Jupyter Lab server, and then you can be on it. But yeah, on the web browser, you can just do whatever you like. And yeah, this is as a test, I fed some of the JETSON README files and trying to see if he can find the right answer. And at the end, it did. So good the same. But along the way, I got to learn like the embedding model's accuracy is kind of important. If that doesn't perform well, of course you don't get to find the right answer, even if your LLM is good.
Yeah, the embedding model is where the magic happens. And with the higher end agents, we're just using Clip, which is like a super heavyweight one. But most of these are like sentence transformers, and yeah, this is really cool though.
Right. The embedding model also runs on Llama or Llama again locally. So yeah, it's all contained and then
and you can just put in like text files and PDFs and like HTML, I think also, right?
Right. All the document loaders are there, so you should be able to ingest all the data. In fact, I'd like to try, but what I realized is I probably at this point need to start curating all the data and then build a test case.
It becomes more about that. Yeah.
Right.
And I think we would love to have a little JETSON desktop assistant that can help you develop the bot that it's going to be deployed on. I think it's like a really funny idea, actually.
That should be good.
And so if you can scroll back down, this particular example was a rather technical one that Chitoku and I went back and forth and worked on a little bit to get it to. We asked it a hard question, which is like, when it's in USB device mode hooked up to your laptop, what is the static IP address of the JETSON? And it was able to go in there and find it from the much larger text file. And as you know, with JETSON, we have like thousands of pages of docs. So hopefully this does bode well for being able to pull out that needle in the haystack. And there's I think there'll be a lot of useful things that people can do this with the edge, since Chitoku, you have this all running on the JETSON, even the ingest part, you can dynamically upload docs and stuff to this.
Right.
Yeah, awesome. So again, these containers are on up there now. You can go around and start playing around with RAG. It's literally like 10 lines of Python code to like open up LlamaIndex, put a doc in, and then chat about that, and it adds RAG in there for you and figures it out. So it is, if you're looking to get started with that, that's highly recommended. All right. Well, it is 15 past the hour. That seems to be our normal running time. The next meeting we will do in 2 weeks on May 29th. Thank you all so much for joining us. We will continue on with our work. I'm going to be continuing to tie up all that video VLM stuff, add it back into the UI, more docs. And I really want to make progress on that controller LLM and get that to be much smarter and start integrating it into Home Assistant and get this system all going, this multi-agent back and forth. Yeah. All right. Thank you guys so much. Is there any more questions? Anybody want to stick around after and chat? I'm happy to. Otherwise, feel free to hit us up on the forums. Thank you, everybody who joined today. This is always such a fun meeting. Otherwise, we'll catch you guys in 2 weeks. Yep. Thank you so much. Cheers. Have a good afternoon or evening, everybody. Bye-bye.
See you.